Hello everyone, I'm back this time with a question from section 15.2, question 9 of the book, which asked us to evaluate the double integral e to the minus y squared over the region y goes from 0 to 3 and x goes from 0 to y. As we know all, if you have a double integral, to evaluate that we have to make it an iterated integral. And to make this guy an iterated integral, first thing to note is that this is type 2 region, meaning that if you wanted to draw that, so you have y going from 0 to 3, so the constant boundaries are for y, and our x goes from y from 0, so my x's go from 0 to the line y equal to x, my y goes from 0 to 3. So when you have this kind of regions, my double integral, I have to put the constant boundaries as boundaries of the outer integral. So 0 to 3, and those are for y. And the inner one, x goes from 0 to a function in terms of y, then you integrate with respect to this. Okay, so my double integral is ready to go, and I'm integrating with respect to x, meaning that y is constant. If y is constant, y squared is constant, negative y squared is constant, e to the negative y squared is constant. So I have a constant. Antiderivative of constant is x times that constant. And this time you go from 0 to y, dy. And fundamental theorem of calculus says that you just plug in there, so y, I'm plugging in this boundary into x. Note that I integrated with respect to x. So I have this guy minus this plugged in x, so I have this dy. This is 0, so my integral is now of this form, y e to the minus y squared dy. This is just regular integral. You have one variable, it is in terms of y, and you have to integrate with respect to that. But the point is that if you look into your table of integrals, you won't find this function, the antiderivative of this function. So you have to do some gymnastics to get that integral. Here, the key point to notice is that I have e to the some function of y. So to be able to integrate, if I change the name of that function in the power of e to u, in other words, I'm using integration, substitution, integration by substitution. So du is going to be negative 2y dy. And I'm lucky because I have y down there, so y dy is nothing but negative half of du. You can see from here. And what about boundaries? When y is 0, then u is going to be negative 0 squared, which is 0. If y is 3, then u is going to be negative 3 squared, which is negative 9. So I have to rewrite my integral completely in terms of new variable, which is u. And here, what I should do. So e to the power negative y squared, it is u, so e to the u. Y dy, I have to put negative half du for that. Lower boundary goes to 0, upper boundaries goes to -9. Now, I have an integral whose antiderivative, I know what it is. This is constant. Antiderivative of e to the u is e to the u. So e to the u, I go from 0 to -9. And then, fundamental theorem of calculus. So you just plug in that, minus half e to the power 0, which gives me negative half e to the power -9, plus half. So, just recap is that you have fundamental, if you have double integral on a given region, first see what is the type of the region, make it to iterated integral, integrate inner one, integrate outer one. And while you're doing this thing, you have to be able to use all the techniques you know for integration. Thank you for watching.